Protons are found in the nucleus, so as neutrons. Neutrons are also found in the nucleus. Electrons are found in the orbitals. Protons are +1 relative charge. Electrons -1. Neutrons 0. Now relative mass. 1, 1, and then okay. Relative mass 1 for protons. Neutrons is also 1. So 1 for protons, 1 for neutrons, but electrons, it's 1 over 1840. So 1840. There's various. Okay, so there are various models for the atomic structure. So protons, electrons, neutrons are the 3 subatomic particles. Protons found in the nucleus, so as neutrons. Electrons found in the orbitals. Protons +1, neutrons 0, and electrons -1. Electrons are electron is different in relative mass, because it's 1 over 1840, whereas protons and neutrons both have a relative mass of 1. Okay, so I understand this. Oh, also, there are various models for the atomic structure to represent it, and it has changed, and it has changed over the years. Okay, so now each element is represented in a specific way. So, for example, we're going to have lithium. So the number of neutrons in lithium is 4, because if we want to find the number of neutrons in an element, we do the mass number, which is always going to be the biggest number, and then there's going to be an atomic number, which is the smaller number. We do the bigger number minus the smaller number. So in the case of lithium, what we do is we do 7 minus 3, because 7 is the mass number and 3 is the atomic number. So to find the neutrons, we do 7 minus 3, which is going to be 4. So in this case, lithium has 4 neutrons. Okay, so I understand this. Atomic number is Z, mass number is A. Okay, so that makes sense. Now we're on to something called isotopes. Now you may wonder, what are isotopes? And yes, that's fine, because isotopes are atoms with the same number of protons, but they have different number of neutrons. So there are various elements which are isotopes. For example, I'm pretty sure there's one like chlorine, perhaps there are some like magnesium and stuff. So isotopes have the same number of protons, but different number of neutrons. Okay, so that's isotopes. And isotopes have very similar chemical properties. So isotopes have very similar chemical properties. Similar chemical properties. But that is because they have the same electronic structure. So they have the same electronic structure because of the protons. I already said proteins. So what we learned so far is that there are 3 subatomic particles: proteins, electrons, and did I just say proteins again? I mean protons, sorry. Protons, electrons, and neutrons. Protons and neutrons are found in the nucleus. Electrons are found in the orbitals. Protons have a charge of +1, electrons -1, neutrons are 0. Now, relative mass, protons and neutrons have the same, it's 1. But electrons is different because it's 1 over 1840. So there are various models for the atomic structure, and it has changed over the years. Now, if we're looking at elements, which are found on the periodic table, we can see that there is a mass number, a symbol, a letter symbol, a letter or letters, shall I say, and there's an atomic number. So for instance, if we have lithium will be represented as Li. Then there will be a 7 on the top, which is the mass number. Mass number is A. Then below it, there will be a smaller number, which is a 3. And it will be the atomic number, so 7 and 3. Now, sometimes we need to know how many neutrons it has. So, what we have to do is the mass number subtract the atomic number. So, in this case, we do 7 minus 3, which will give us 4. So the number of neutrons in lithium is 4. Isotopes have the same number of protons but different number of electrons. They have the same chemical properties because they have the same electronic structure, but they have a slightly different physical property because their mass is different. So they have a different physical properties due to the difference in mass. Okay, now we've come to this. Now, this kind of looks horrifying, but trust me, it's okay. So this is called the time of flight mass spectrometer. Spectrometer, yeah. Spectrometer. Okay, so what is the time of mass spectrometer and what is it used for? Well, the mass spectrometer can be used to determine all the isotopes present in a sample of an element and therefore identify elements. So let me write this down. So it can determine isotopes that are present, and therefore we can identify what element it is, which is amazing because us chemists and, well, chemists, they want to find out everything, so we use this. Okay, one important thing that you need to remember is that it needs to be under a vacuum, and by that I mean there's no other particles apart from the ions, because if it's not in a vacuum, the air particles would ionize and register on the detector, and we do not want that because we want it to be pure. We want to know exactly what element that is. So I'm going to put in capital letters that it needs to be in a vacuum, so that air particles don't get ionized, so they don't get ionized and don't get registered. Okay. Now there are steps in this. So the first step in the flight of mass spectrometer is ionization. Now, what is ionization? Well, the sample can be ionized in a number of ways. Okay. So two of these techniques are electron impact and electrospray. So there's two ways. So I broke my pen. Electron impact and electrospray.